Module 00, Revit in a nutshell. Welcome to the foundation of our Revit MEP journey. This module sets the stage by unpacking what Revit is, why it matters, and how it compares to traditional 2D computer-aided drafting workflows. We begin with Revit in a nutshell, a high-level overview of Revit as a building information modeling BIM platform. Unlike 2D computer-aided drafting, Revit models are intelligent, coordinated, and parametric, meaning every element knows what it is, how it behaves, and how it connects to others. Next, we ask, what is Revit MEP? Revit MEP is the discipline-specific environment for mechanical, electrical, and plumbing professionals. It allows us to design systems that are not just spatially accurate, but functionally connected. We then explore Revit's core capabilities, including 3D modeling, system intelligence, scheduling, annotation, and collaboration. These tools empower us to design, document, and coordinate with precision. Why it matters? Because Revit supports integrated workflows, reduces errors, and enhances project delivery. It's not just a drawing tool, it's a decision-making platform. We'll also look at an example in practice showing how Revit MEP supports real-world coordination between disciplines from duct routing to electrical panel placement. Finally, we'll do a quick comparison between Revit and traditional 2D computer-aided drafting. 2D computer-aided drafting is line-based and static. Revit is object-based and dynamic. In Revit, a change in one view updates across all views, saving time and reducing risk. This module is all about mindset, shifting from drafting to modeling, from isolated drawings to integrated systems. Revit in a nutshell. Let's begin by defining what Revit truly is. Revit is Autodesk's flagship building information modeling (BIM) software, designed to empower architects, engineers, and construction professionals to create intelligent 3D models that go far beyond geometry. It's not just about drawing lines or shapes. Revit integrates geometry, data, and workflows into a single coordinated environment. Every element knows what it is, whether it's a duct, a light fixture, or a wall, and it behaves accordingly. This means that when you place a component, you're not just drafting, you're embedding rich metadata that supports analysis, scheduling, and lifecycle management. Revit enables collaboration across disciplines, allowing mechanical, electrical, and plumbing teams to work within the same model, reducing clashes and improving coordination. In short, Revit is a platform for design intelligence where every decision is traceable, every change is synchronized, and every model is a living representation of the building's intent. What Revit is. To truly understand Revit's power, we need to unpack its core identity. First, Revit is a BIM platform, building information modeling. That means every element in your model, whether it's a wall, duct, pipe, or circuit, carries not just geometry, but metadata. Now, you're not just drawing metadata, you're embedding intelligence. Second, it's built on parametric modeling. This is a game changer. When you modify a component, say a duct size or a room boundary, Revit automatically updates every related view, plans, sections, elevations, and schedules. No manual chasing, no missed updates. Third, Revit is a multidisciplinary tool. It supports architecture, structure, and MEP design in a unified environment. That means better coordination, fewer clashes, and smoother workflows across disciplines. And finally, Revit offers lifecycle coverage. It's not just for design, it supports construction sequencing, documentation, and even facilities management, making it a long-term asset, not just a design tool. This topic is about seeing Revit not as software, but as a strategic platform, one that connects design intent with execution and long-term building performance. Core capabilities. Let's now explore the core capabilities that make Revit such a powerful tool for MEP professionals. First, 3D design and visualization. Revit allows us to create detailed models with realistic perspectives, walkthroughs, and renderings. This isn't just about aesthetics, it's about communicating intent and verifying constructability. Second, coordination and collaboration. Revit supports multi-user access to the same project file, enabling real-time collaboration across disciplines. This reduces clashes, improves efficiency, and keeps everyone aligned. Third, data-driven documentation. Schedules, legends, and annotations are generated directly from the model. That means your documentation is always synchronized with your design. No manual updates, no inconsistencies. Fourth, systems integration. Revit lets us model HVAC, electrical, plumbing, and fire protection systems with intelligent connectors and rules. These systems aren't just drawn, they're simulated, analyzed, and coordinated. And finally, family editing. You can build reusable parametric components like ducts, fixtures, and valves that adapt to project needs. This gives you control, flexibility, and consistency across your models. This slide is about capability, showing how Revit empowers you not just to draw, but to design, coordinate, and deliver with precision. Why it matters. Now that we've explored what Revit is and what it can do, let's talk about why it truly matters in practice. First, efficiency. Revit eliminates repetitive drafting by linking views and automating updates. A change made in one view reflects across all others, saving time and reducing manual errors. Second, accuracy. Because geometry and data are embedded and synchronized, Revit reduces inconsistencies and improves design reliability. What you see is always aligned with what's scheduled and documented. Third, collaboration. Revit enhances communication between architects, engineers, and contractors. Everyone works within the same model, reducing clashes and improving coordination. Fourth, compliance. Revit supports industry standards and helps align with BIM mandates, which are increasingly required in public and private sector projects across many regions. And finally, lifecycle value. Revit provides a digital twin, a model that continues to serve after construction, supporting facility management, maintenance, and future upgrades. This slide is about impact, showing how Revit transforms not just how we design, but how we deliver, operate, and sustain buildings. Example in practice. To see Revit's power in action, let's walk through a real-world scenario, designing a hospital. Architects begin by modeling walls, floors, and spatial layouts. These elements define the structure and flow of the building. Engineers then layer in the systems, HVAC ducts, electrical circuits, and plumbing networks, all within the same coordinated model. As components are added, Revit automatically generates schedules, like equipment lists and fixture counts, directly from the model data. Now imagine a design change. A wall is moved. Instantly, all connected systems, ducts, pipes, circuits, update. Views, tags, and schedules adjust automatically. No manual redrafting, no missed updates. Contractors use the same model for construction sequencing and cost estimation, ensuring that what's designed is buildable and budgeted. This slide is about integration, showing how Revit supports a seamless workflow from concept to construction across disciplines and phases. Quick comparison. Revit versus traditional computer-aided drafting software. To wrap up this module, Let's compare Revit to traditional computer-aided drafting software and highlight why the shift to BIM is transformative. First, geometry only. Traditional computer-aided drafting software focuses purely on lines and shapes. It's visual, but not intelligent. Revit adds data to geometry, turning drawings into smart models that carry meaning and metadata. Second, automatic updates. In traditional computer-aided drafting software, every change must be manually replicated across views. In Revit, updates are automatic. Change a component once, and every related view, schedule, and sheet reflects that change instantly. Third, multidisciplinary use. Traditional computer-aided drafting software is often siloed, separate files for architecture, structure, and MEP. Revit supports full integration, allowing all disciplines to work in one coordinated environment. Fourth, collaboration. Traditional computer-aided drafting software relies on file-based workflows, passing versions back and forth. Revit uses a central model with work sharing, enabling real-time collaboration and reducing version conflicts. And finally, lifecycle management. Traditional computer-aided drafting software stops at design. Revit supports the entire building lifecycle, from design to construction to facilities management, delivering long-term value through a digital twin. This slide is about evolution, showing how Revit moves us from static drafting to dynamic modeling, from isolated files to integrated workflows, and from short-term drawings to long-term building intelligence. End of the module. That wraps up our presentation. If you found this module insightful, like and subscribe to support the channel. It helps us keep delivering high-quality content for professionals like you. Comment below with your thoughts, questions, or feedback. I'd love to hear how this foundation is shaping your understanding. And most importantly, thank you for your time and focus. You've just taken the first step toward mastering a powerful platform that transforms how buildings are designed, coordinated, and delivered. Let's keep the momentum going. Let's move on to the next module